class we have seen the concept of NAND realization, right? So and also we have seen the another realization, that is NOR realization. Means when you are going to have a terminology called sum of products expression or an expression called product of sums expression, we can able to easily implement it using NAND gates. If it is product of sums, we can able to implement it using NOR gates. Why? If it is in the form of sum of the products, we can able to easily implement with the help of AND OR gates. AND OR gate, right? If it is in the form of product of sums, we can able to easily implement with the help of OR AND gates, right? For example, if you take AB plus CD is a kind of a Boolean function or a Boolean expression, right? So it is in the form of sum of the products, right? So if you take AB implementation, it will look like this AB, and if you take CD, it requires one AND gate. And if you are going to perform OR operation, these two outputs should be attached to one more OR gate. One more OR gate. Finally, you are going to get AB plus CD as the output, right? For example, if you would like to implement it with help of NAND relation, what you will do simply, can simply bubble up output of AND gate, bubble up, and inputs of OR gate is going to be bubble up, right? So finally, your input OR gate is going to bubble up with bubbles. So this gate will be indirectly acting as NAND gate. So this input will be given to like this, and this input will be given to like this, so that it is the implementation of NAND realization. Okay, means if you are able to observe here, how many levels are there, ma? These first two AND gates are from level 1 and the output gate is at level 2. This is what we can call it as two-level synthesis. Two-level synthesis, meaning that whatever the circuit that you are trying to construct, that circuit is having two levels. When if you are going to follow the approach of sum of the products approach or product of the sum approach, you will get two-level synthesis. Means, for example, I am trying to take only A plus B into C plus D, right? So first expression you are going to get with help of OR gate, second expression you are going to get with help of OR gate, finally you are going to perform AND operation, right? So this first level we call it as level 1 and second level we call it as level 2. You are going to get the result, right? Meaning that simply if it is in the sum of the products or in the product of the sums, you are going to get two levels. You are going to get two levels. That is what you can call it as two-level synthesis mechanism, right? Sometimes if you are able to observe the XR implementation, how many NAND gates are required? 4 NAND gates are required, right? Basically, if it is like XY bar plus YX bar, how many levels are required here? How many levels are required? Try to observe here. So assume that this is X and Y bar. My output will be like this, and YX bar output will be again an OR gate. Again, it's a kind of two-level gate. But if you are going to implement with the help of NAND, how many how many NAND gates are required? 4 NAND gates are required, right? If it is in the form of NAND realization, you require 4 NAND gates. 4 NAND gates, right? So at that situation, how many levels are there? See, if you are going to observe the example, right? If you take this one, up to here we call it as level 1, and this level we call it as level 2, and this level we call it as level 3, right? Meaning that if you observe any circuit, if the circuit is having more than two levels, I can call it as multi-level synthesis circuit. Meaning that it is going to have more than 3 levels. So at what steps you are going to get more than 2 levels? If the expression is either not in the form of sum of products or not in the form of product of sums, then you may get as multi-level expression or multi-level synthesis, right? For example, try to take ABCD is one kind of expression, right? So if you would like to implement it with help of 2 input AND gate, how many levels are required? I think 3 levels, right? AB is an input, this output you need to connect it to C. Again you are going to get one output as ABC. Again this output you need to connect it to one more gate. This is what I can call it as ABCD, right? This is a simple example what you mean by multi-level synthesis, right? In multi-level synthesis you are going to get more than 2 levels. I can call it as multi-level synthesis. For example, if you try to take this example, f function f equal to a into b plus cd or c bar d, right? If you are able to try to construct the circuit, you are going to get more than 2 levels. Why? First I am going to take a as input directly, then I need to construct b, it is okay. Then I need to take cd. For this cd there should be an AND gate required. This AND gate is going to perform OR operation over b. You are going to get next level. Right? For this next level, what you require? You require to have AND gate, meaning that level 3 is there. Right? Now this output you need to perform with again C bar D. This will be like a complementation. Again it will be like a normal operation, and these two will be the OR operation, right? So if you are able to observe, this is level 1, level 2, level 3 and level 4, right? So this is what I can call it as multi-level synthesis, right? So when there is a chance to get multi-level synthesis, if the expression is not in the form of sum of the products or not in the form of product of the sums, definitely you are going to get multi-level synthesis. In all the remaining cases you are going to get only 2-level synthesis.